Hi, welcome to this series of lectures on cloud computing. Today we will be discussing on one aspect which is sometimes considered as one of the major prime mover or building block of cloud computing, that is web services and service oriented architecture. So, we will look at that what exactly it means and try to have a overall a overview of the whole thing, so that it will help us in understanding the rest means that how it build up and how things are going on. Now, what are web services? There are several definitions you will find in the literature and the internet. So, like if you see the W3C web service architecture requirement specification, it says that a software application identified by a URI whose interfaces and bindings are capable of being defined, described, discovered as XML artifacts. Okay. So, this is a very versatile definition. So, what it says that the software applications which are identified by URI and whose interfaces or bindings are capable, so that you can define, you can describe, you can discover, and all is underlining XML based languages, right. Whereas, if you look at the Microsoft, defined as a programmable application logic accessible using standard internet protocol, right. Other definition, an interface that describes a collection of operation that the network accessible through standardized XML messaging, and software components that can be spontaneously discovered, combined, recombined to provide solution to the user's problems and requests, right. So, from this different sort of definitions, what we can see, one thing is there, that is it is a XML based phenomena, right. So, XML as you know, it is a more of a data transformation language. It helps in interoperability and helps in application talking to each other, right. So, web services are those type of services which are available on with can be defined in the can be accessible through a standardized URI, and it works on a message exchange type of protocol which is based on XML, right. So, what it gives us? It gives us any application can now two application can talk to each other. I am not bothered about what is at the background of the how things are there. I only bothered about where the service is available and how I can talk to that services, right. I do not bother about the background processing of the things. This also helps in bringing this legacy application to talk to other applications, right. So, this is a different way of looking at the things. Those who are accustomed with client server type of protocol which are more tightly bound, this is more loosely bound and can talk to each other very easily. And if you look at the, if I say the genesis or the history of the things, so there are different aspects which helps or which promoted these web services. One is definitely structured programming, which evolved to a next generation of object oriented programming. Distributed system, as we have discussed in our previous lectures. So, it played a different very important role. There is another concept of electronic data exchange between two entities, primarily two business entities, when they want to interface their data for some particular purpose. Of course, this World Wide Web, which allows the whole computing phenomena to connect to each other, right, with backbone internetworking, primarily driven by internet protocol. So, these are this is also a one of the phenomena. So, these are all this component has all these components have now has what we say facilitated that this development of web services or the evolution of web services. Now, distributed computing, where I am not going any detail, because as we have talked in detail, talked in length that in our previous lectures. So, one of the issues whenever we are doing distributed computing is interoperability, right, one of the major issues other than networking and other type of things. So, ability to communicate and share data with software from different vendors and platform, very interesting phenomena, and which allows this whole world of or whole gamut of applications to talk to each other. That is, it allows you to communicate shared data software from different vendors to platforms. Limited among conventional proprietary distributed computing technologies, like in case of interoperability there is more limited scope. So, we need to expand it. There is another major development means in this area is the EDI, or which is popularly known is the electronic data interchange, that computer to computer exchange of business data and documents between companies using standard formats recognized both nationally and internationally. That means, it is primarily a business data or formats, but the formats are recognized by the both the parties. So, I understand that the organization A's system understand what type of message is coming from the organization B, and then go on exchanging. The information used in EDI is organized according to a specific format set by both companies participating in the exchange. So, it is important that the format is somewhat pre-known or predefined, that how or exchange, that format or the schema is exchanged previous to the exchange of the data. So, other party knows that what sort of data is expecting. There are lot of advantages, like one is that low operating cost, because you do not bother about when exchanging data. Less error, more accuracy, because this data exchange phenomena loop is not there. So, no data entry, less human error. So, directly getting the data from the other things, increased productivity obvious, and faster trading cycle if there are multiple companies are working together, that is one aspect. Now, all those things has somewhat facilitated this, as we are discussing, is that web services. So, it takes the advantages of object oriented programming by enabling developers to build application from existing software component in a modular approach, right. So, it helps developer to develop applications and from their legacy things or the existing thing, and help them to different component to develop different component in a modular approach. So, transform a network, that is internet, into a library of programmatic components available to the developers to have significant productive gains. So, if you look at it is a as if the library of different programmable components are there. Now, you can go on building things to make your application run, right. So, one, if we will take a type of example that this how these services are exchanged, is maybe what we can think of is our this online reservation or booking systems, right. I book a train or say flight. So, I have the I gave means when I do when we use a particular address or URI to access that, and then those in turn say any that particular travel portal is not having neither having flights nor having hotels or not having anything, right. So, it in turn talk to the other different airlines services, pull the data, show to the user, it selects, and then if the booking process goes on, then it goes on through a credit card, debit card, net banking. So, other services are called. So, if we see there is a multiple services are being amalgamated in a proper choreographic way to execute a job. So, my job was to select say a best possible flight based on my budget and my convenience of time, and I want to do it online. So, I go for a sort of a travel portal, or what we say some sort of a broker, right, which allows me to see different airline stuffs, and then I select my suitable things, go on paying through my credit card, debit card, etc., and then I get the ticket generated, right. So, see, neither this airline organizations, they are directly, I am not directly hooking to them, they are being connected. Neither this your credit card or debit card service provider have any clue that whether you are buying a ticket, etc. So, what it says that if it gets a request in a particular form, it will acknowledge it and reply it on a particular form, right. So, that means it is a some sort of a XML type of message exchange going on to the things. So, this allows us to generate different type of mega applications or using some different type of different software components or different type of other applications. So, I can mix and match and doing the things, and it goes on a choreographic way, least minimal involvement of the different service provider, and it goes on like that. So, if we see that improved distributed computing interoperability by open non-proprietary standard that can enable theoretically any two or more software components to communicate. So, it uses a open standard and facilitate interoperability, as we are discussing about XML and type of things. So, it provides capabilities similar to those of EDI, like exchanging data, but are simpler and less expensive to implement. Like I do not have any sort of a predefined agreement on the data format, etc., right. Rather somewhere other I should able to know that where the things goes on. Configured to work with EDI systems, can be configured to work, allowing organizations to use two technologies together or to phase out EDI while adopting web services, right. So, unlike WWW or World Wide Web, separate visual for non-visual components, right. So, this is important. One is that what I visually see, right. Another is that what goes on the background. So, these two things are separated. Like if you look at the XML type of things, XML is more of a data transformation language. So, it is not a data visualization language. In other sense, HTML, as we know, is more of a data visualization, or it displays the things, right. So, XML more work on interoperability type of issues and how data will be exchanged and so on and so forth. So, XML with styling of the XML plus styling of the data will help in visualize or displaying the data. So, unlike our normal HTTP based things which displays the thing, it is more of a data representation or data transformation type of stuff. So, interaction may be either through browser or through desktop client, like can be Java Swing, Python, Windows, etc. It can be there different type of desktop clients we can interact with the things, or the common interface is the interfacing with the browser. Now, web service, if you look at, it tries to address three major components: interoperability, like lack of interoperability standard in distributed object messaging. So, interoperability between two software, between two parties, firewall traversal. Now, as the web services piggyback on different internet or TCP IP based protocols, primarily HTTP protocol. So, it can basically go over the firewall. Most of our firewalls are HTTP at port 80s are allowed. So, web service things can still work on the things. So, CORBA and DCOM use non-standard ports. Web services use mostly the HTTP. So, it is not only HTTP, it can use others, but primarily HTTP. Most firewall allows port 80 HTTP, leading to easier dynamic collaboration, that is one major aspect. And complexity, web services is a more of a developer friendly service system, right. So, it is much easier to develop. So, use open text based standards, like one of them is XML, which allows components written in different language or different platform to communicate, right. So, this is important. So, and it can be implemented incrementally, right. Not on the day one everything has to be done, rather deployment also can be done incrementally, rather than all at a once, which lessens the cost and reduces organization disruption from the abrupt switch to the technologies, right. So, these are the different aspects. Another major aspect is still your organization can run their legacy software and tools, which are if you have proper web service interface for the external world. So, if we just try to again sum up that communication via open standard, like it can be HTTP, it can be SMTP or any type of any other TCP IP application layer protocol meant to be there. Process of XML messages framed using SOAP, we will come to that what is SOAP and type of things. So, it is primarily XML based messaging system, and one of the popular thing is the SOAP. Describes these messages using XML schema. How my data is organized, I can basically describe it using a XML schema. Provides an endpoint description using WSDL. We will again see what is web service description language. So, where my web service is launched, how it is configured. So, we can do it at a WSDL, and basically I can publish and discover using a UDDI. So, my web service description, discovery and integration, it is facilitated by the UDDI. So, one way of implementing is that we have XML as the base, and we have three major component: SOAP, WSDL and UDDI, right. So, this is the things, all are W3C compliant and use the de facto XML based things. We will just look into that how things works. So, say a purchase one example. So, as if purchase order goes, then credit check, reserve inventory, credit response, inventory response, consolidate result and return to the invoice, right. So, there are different parties like credit service, inventory service, PO services and so forth, and those are can be choreographed to service the things. It is taken from a resource, but what it tries to show that I can provide different type of services, I can compose it and create a larger application, bringing different type of application into the things. This application when choreographed to other type of things or integrated in a other fashion can give some other type of services. Now, looking at this whole thing, it has we evolved to another this overall architecture, what is the web service oriented architecture or SOA. So, IBM has created a model to show web service interaction, which is referred to as service oriented architecture consisting of a relationship between three entities. So, with this basic philosophy we have three entities, one is a service provider, one is a service requester or service consumer, and there is a service broker, right, or there is a something which allows this consumer and provider, requester or consumer and the broker and to talk to each other to find where the services are there, etc. So, if we look at this figure, a very popular figure available in you will find it in different literature. So, I have the service requester or the consumer which wants to get the services to the from the service provider, but how the service requester find that where its services will be there. So, there is a registry where it can find out, right, that which type of services are there. If I try to look at a analogy, those who have seen our because nowadays this is more or less obsolete, our telephone directory, right, which comes up from telephone exchange. So, there is to be things like at the beginning that yellow pages, white pages and so forth. So, where you find that where to find what, rather the directory itself tell you that by how to search for a particular thing, like suppose you are looking for plumbing service or something. So, you go and live through the thing, etc. So, it acts as a directory service, right, or registry service. So, that type of things is here also required, which basically have a registry service. So, it is there are service description out here, the service requester finds the this its request required service from this registry service using that WSDL and UDDI, and then basically bind with the service provider it goes for. It can find more than one service provider and so forth. A service provider, once a new service is launched or once a service is updated, it is basically it publishes the service in the registry. So, that prospective buyer or prospective consumers consumer or requester can find that where this type of services are there. So, you can find that this is a triangle where different component works, and if anything is developed based on this type of things, what we say that it is a service driven or service oriented architecture. So, if we look at that web service model that the roles of web service architecture, the service provider, owner of the service, platform that hosts access to the things, service requester, business that requires or the consumer who you want to consume, and service registry, searchable registry of service description where service provider publish their service description. So, three major operations in the service web service architecture. One is publish, to publish the service provider things, find, the consumer finds the things, and bind, once is find and it finally binds with the service consumer with the provider. And one of the popular component is there are others also, that is one is which are the component, one is the XML, extensible markup language. I believe all of you know, if if not, you should go through any standard book or even W3C tutorials where you will find a good tutorial on XML. So, its uniform data representation and exchange mechanisms it provides. SOAP, simple object access protocol, right, a standard way for communications over using again XML. WSDL, web services description language, uses XML and it is a standard meta language to describe the service offered. And UDDI, universal description, discovery and integration specification, it helps us in building up the registry service, and a mechanism to register and locate web service applications. So, we can look at other way, as we have seen that the client goes for the client queries the registry to locate services, registry refers to WSDL document where the description is there, the client accesses WSDL document, WSDL provides data to interact with the web services, and client sends SOAP message to the SOAP message request to the provider, and service returns from the SOAP message from the response. So, that is somewhat binding with the things. And these are the different components. This underlining thing is that it works on the internetworking or our standard network protocol TCP/IP or OSI. So, this is the backbone. Over that SOAP messaging, the description, the UDDI can be a static publication or it can be a dynamic publication, and then there are other things like WSFL, that is flow management and type of things. So, for other type of aspects, and there are three other components, it goes hand in hand. One is the quality of service, that what sort of service they are giving, or QS, management issues, that how whole thing can be managed, and then the security aspects, like in doing so whether there is a security breach, how to things, what will be the security policies, whom to trust, and all those components will be there. XML I am not dealing in details, it is a standard generalized method of generalized markup language is evolved from. It is a extensible markup language primarily used to describe data, and it helps in separation of content from the presentation. An XML document can be optimally referred to by a DDD, the more popular is XSD, the XML schema definition language, schema definitions, so that whether we can the schema is defined. So, in case of XML, tags are not predefined. So, you can define your own tags, unlike HTML, enables cross platform communication in web services. So, this is a typically a XML thing, like it describes. So, sorry, it is a HTML thing, like it basically shows that how a particular person is address of a person and email address, etc. The contact of a person called John Doe is defined. And if we use this HTML in standard any browser, so it will show like this. However, if I want to look at the same thing as a XML, so you see this is more of a data description, right. So, it is a name, it is a address, this is the country, phone, email and type of things, right. So, this is a XML type of things, it is not a representation. So, for representing we need to do something more. So, as we are discussing three major component, one of the thing is SOAP, is a more of a messaging protocol, like simple object access protocol, format for sending messages over the internet. It is XML based, W3C compliant, and stateless and one way, uses mainly HTTP as the what we say transport protocol. This transport protocol should not be mixed up with our TCP IP transport protocol. This is transporting these web services. So, here the HTTP acts as the carrier protocol. So, there are different building block. I am not going to the nitty-gritty of the things. So, how a SOAP buildings blocks are there. So, transport protocol is the overall envelope, then the MIME header is there, then SOAP envelope, SOAP header and SOAP body, and there are fault identification scenarios, but all are XML based. So, message structure, it goes on a SOAP envelope and goes through this, its piggyback on this transport, basically become a envelope or and become a payload for this transport protocol, in this case HTTP. Again I am repeating, this transport protocol should not be mixed up with our TCP IP or OSI protocols. The SOAP request goes like that. If you see, this is a post message in our HTTP stuff, and the SOAP message, in this case it goes for a get a particular stock price and stock name, particular maybe the IBM and so on and so forth, and the response is again if you see that a HTTP response, and it responds with a again a value. So, it is more of a structured way of exchanging data. It does not say how it can be displayed. For the display, you need to have a HTML type of stuff. So, why SOAP? It is a there are other technologies which are not could not do this type of application to application. SOAP is a platform neutral choice, simple XML wire format, places no restriction on endpoint implementation of the technology. So, that you can run your legacy things, etc. There are major three characteristics: it is extensible, neutral and independent. So, this is exactly suited for our distributed applications talking to each other and type of things. And there are different uses models. One can be RPC like message exchange, or SOAP specification allows any kind of body content and so on and so forth. And there are other security aspects, we are not going to that, we will talk about this when we talk about cloud security. The other one is the WSDL, web service description language. So, it allows to, it is again XML based, W3C compliant, allows to describe the language. So, it has different structure, that what will be the port type, where the how can be defined that where the particular services will be enabled and how where things will be there, the message, types of message and so on and so forth, how this binding process will go on between the service provider and the consumer. So, it is a simple WSDL message. It is a binding, see that, see it is a SOAP message with the WSDL, the SOAP message is bind with these things, that means the description over that, the messaging of the SOAP message, how the data is transferred over that things is bind between the source and destination, or any like from requester to the UDD, from the registry to the consumer and so on and so forth. Finally, we have the UDDI, Universal Description Discovery and Integration. It is a registry service, right. So, a framework to define XML based registries, so that all these metadata informations are there, where from this consumer or the requester look for that particular services and how to bind with that particular provider and so on and so forth. So, it is service provider, registry and requester, just if you remember the previous couple of slides before. So, it is just little bit what we say, that orientation is different. So, the registry, the service provider publish it, requester finds it and binds with the things. So, it plays extremely important role for keeping the whole things working together. So, if you the same thing, it basically publish another thing, the consumer search and go on binding with the provider. There are several benefits. Any registry service gives a benefits of keeping the data in a particular format, so that it can be searched. So, making it possible to discover right business from the millions of currently online. So, you can finding how to enable say connectivity with the preferred business and so forth. We will not go to the detail of the things, this security will work. So, security becomes another important aspect of SOAP, aspect of web services. It works on a vertical line, as we have seen in our previous some of one of our previous figure, and it has different components like web service policy, trust, privacy, secure conversion, federation and authorization and different type of components. So, this becomes a integral one. There are other things like management and QAs which also works. So, what we are tried to see in this particular lecture is that this web services and service oriented component, service oriented architecture is plays a important role in setting up this cloud. The whole cloud process, if you see that IaaS, if we PaaS or SaaS, say X or anything as a service. So, its basic building block is the web services. All these phenomena of web services of publish, bind and find, bind and publish, find and bind, this also is true for the things. Whenever we have cloud services, so I need to basically look at who is the service provider and consumer. I need to know that where the service is launched and type of things, right. So, this is being extended in appropriate way to realize these cloud services. So, it plays this development of web services and service oriented architecture has played a important role in bringing this cloud as this cloud computing as a viable things. So, we will stop here today and we will continue in our future lecture with other aspects of cloud computing. Thank you.